Welcome back once again to another exciting episode of Dave Does Math from Home. Today's episode of Dave Does Math from Home is going to be part one of our discussion of the product and quotient rules. We remember from section 3.3 that multiplication and division are not safe. We can get derivatives of things that are products or quotients, but it doesn't work in like the simple, intuitive, straightforward way you would expect it to work. It's not a complex thing, it's just not immediately obvious. But we can make it obvious if we explore some other ideas. So let's start with a product function, a function that is the product of two other functions. And let's start with something really simple like x cubed times x to the fifth. This is a really good function for exploring the product rule because we can just simplify this and then take a derivative there it is. This is what f prime of x is. This is going to help us out a lot because we can go back to this as originally written as a product, and we can sort of experiment with these things and see what we need to do in order to arrive at the correct answer. Like, we know that this has to be the correct answer. It's very straightforward if you just simplify it and then take a derivative. So we know where we need to get to. Now we can come back to where we started and figure out how we can get there while still treating this as a product. So for now, let's see what happens if we just take the derivatives of these things individually. This is a 3x squared. This will give me a 5x to the fourth. Neither of these things is this. And if we multiply them together, it's also not going to become this. If we multiply them, we would get 15x to the sixth. That's not even close to this. So there's another sort of benefit of doing the easy problem. We can see very clearly that multiplying these two derivatives will not get us the correct answer. So we need to think about what can get us the correct answer. We need to turn this 3 and 2 and 5 and 4 into an 8 and a 7. I think probably the first thing we could do is look at the coefficients. I got the 3, I got the 5. If I could add these things together, it would bring me to this 8. So there's a connection I can draw right away. 3 and 5 will give me the 8. If I could somehow add these together, before I add these together, I need them to have the same, I need them to be like terms. So I can't just add the x squared and the x to the fourth. Those aren't like terms, I can't combine them. If I want to add this 5 and the 3 to get the 8, first I need both of these things to be x to the seventh. In order to get this thing to become an x to the seventh term, I would need to multiply it by x to the fifth, which is conveniently what that thing is. If I want to get this to be an x to the seventh term, I would have to multiply it by x cubed, which is weirdly what that is. If I do this, now I have 3x to the seventh here and 5x to the seventh here, and now I can add them and get 8x to the seventh, which is the correct answer. So here's a technique that worked for this specific problem. Before we commit to this technique, let's see if this works for other problems. Let's take a look at something wooly g of x. Let's say I have nothing planned, I have nothing written. I'm just going to make up some numbers. This one was planned. This one will be improv. Let's make up numbers. Let's do 11 and 7. 7 should be fun. 7, 11. Okay. If I take the derivatives of these things individually, the derivative of x to the 11th should be 11x to the 10th derivative of x to the 7th. These are derivatives. These straight arrows are derivatives. Derivative of x to the 7th should be 7x to the 6th. If I'm going to utilize this same technique, I have to multiply each of these things, each of these derivative pieces, by the other part of the original function. So this is the derivative piece that came from x to the 11th. So I'm going to try multiplying that by x to the 7th. That's the original here. This is the piece that came from the x to the 7th, so I need to multiply that by x to the 11th. That's the original there. And then, if this pattern is reliable, I can just add them together to get the correct answer. That would give me 18x to the 17th. Let's see if this is actually correct. Again, I chose a problem where we could just simplify it very easily. We'll get x to the 18th, and then we can take a derivative of that and get 18x to the 17th. So, this pattern seems to work for these problems. Let's apply it to bigger and better and more exciting things that we can't just easily do like this. So let's take a look at something like f of x equals 3x to the 5th times e to the x. This seems like a good one. Mostly because, unlike the other two problems we just did, this one can't be simplified. There's nothing we can do to this to make it into a nice, simple power rule event that we can just find the derivative of instantly. The only way to handle this, if we want a derivative, is to use the product rule. So, let's try that. We need a derivative of this. That'll be 15x to the 4th. I need a derivative of this. That'll be e to the x. That's the nice thing about e to the x. I need to multiply this derivative by the original other piece. And I need to multiply this derivative by the original other piece. So this is what, 3x to the 5th times e to the x. And then I can add them together. This should be the derivative of the product. And honestly, I'm just going to leave it like this. This is f prime of x. We could simplify this if we really wanted to. We could like factor out an e to the x and a couple of these x's. We could probably factor out the 3 as well. I don't care. In fact, no. It's more severe than that I don't care. I actively would prefer that no one does that. If I'm looking at an answer and it looks like this, I can very clearly see where each piece came from, and it makes grading this work extremely easy. If there's a mistake somewhere in here, like if this is a 16, I can see where that came from. I can see that the rest is correct. Grading is very simple if you just do the product rule and leave it alone. If you try to simplify this and change it and turn it into something else or something more fancy, first of all, if you made a mistake in this math, that's going to make it really hard for me to find where that mistake was, because I can't just look at your answer and see that it's correct. Second of all, if you do more steps, you might make a mistake in one of those, and now you're losing points for something that you didn't even have to do in the first place. Don't do that. Get your product rule, leave it alone, put a box on it. No more simplification. Don't mess with it. Just leave it alone. You're good. So, this is f prime of x. The power rule we found is a really nice way of being able to express a nice, what am I saying? can be expressed very nicely with a couple symbols. This is the product rule, and there are a couple ways that it gets expressed commonly. I'm going to show you the way that I personally think about the product rule. I mean, first of all, I guess if you want to just draw this with your two derivatives and then your extra pieces and a plus sign, that works great. Keep doing this. Perfect. If you want to start trying thinking about this in a more like streamlined, sort of formulaic kind of way, the way that I think about it is derivative of the first times the second plus the first times the derivative of the second. And this is, these ones and twos they're my notation. D means derivative of, so this is derivative of the first, this is the derivative of the second, this is the original second, the original first. That comes from this being the original first, and this being the original second. So this is how I think about it. I think about it using the words first and second, because it's a product, there's two pieces, first piece, second piece. And I think about it in terms of derivative of the first and the derivative of the second. I would be remiss in my duties as an instructor if I didn't show you how the book presented this. The book presents the product rule like this. D dx means derivative of f of x times g of x. So this is the derivative of the product f times g. Is f prime x times g of x, which is basically just a really fancy way of writing the derivative of the first times the second. This prime means derivative of the first, g of x is the second, plus f of x times g prime of x. Again, this is just the first derivative of the second with its g prime. Both of these things say the exact same thing. One of them is more formal, which is why it gets printed in textbooks. It's also a lot more obtuse, which is why I don't like it. I like these. This is very simple to me. Write down whatever you like. Maybe you want to write down words. First times the derivative of the second plus the second times the derivative of the first. However you say it, however you write it, get it written down, get it in your notebook, study it. It's going to be important. Homework has lots of opportunities to practice this. I will leave you to it. For now, I'm going to cut this video and we'll start part 2 talking about the quotient rule, which is somehow much, much worse.